So let's see how you did on those problems. We're going to do problems 4 through 6 now, just to make sure everybody's really comfortable with it. So, type A woman. We're doing problem number 4, same page 71. A type A woman whose father was type B marries a type B man whose mother was type A. Okay, that's like a soap opera, but we'll try to figure it out. So, the type A woman. So we know if she's blood type A, that she must have at least one A. Now, she had to get one of her genes from her father, and it says that her father was blood type B. So if Daddy Dukes had a B, what is the only other thing he could have that he could pass on to his daughter that's not going to affect his blood type, but also not affect hers? Because if there's a B here, then if he gave her the B, she would be AB. That wouldn't work. And if it was an A, that would make him AB. Also doesn't work. So the only option left is that he was heterozygous with an O. So he passes on an O. So she's still a blood type A, but he's passed on this hidden recessive O. Same thing for the man. He is a blood type B, but his mother was blood type A. The only thing an A can pass to a B that's not going to somehow affect their blood types is the O. So this makes the most interesting combination because you have the most possible outcomes. You could have the A matching to the B, and you would have a phenotype child that is AB. You could have the B matched to an O. The O is recessive, it hides, and you have a blood type B child. Maybe you match it to the A, and A to O, you're going to have a blood type A. And when you match O with O is the only time that recessive trait is going to come out, and we also have blood type O. So all 4 of the blood types are actually possible from 2 parents with different blood types, if they happen to both be recessive. Okay, hopefully that makes sense. So problem number 5, what is the probability that a couple whose blood types are AB and O will have a type A child? Okay, so for our Punnett square, we have a parent who is blood type AB and a parent who is blood type O. So the A's can match to the O's, and we end up with a blood type A, or the B's can match to the O's, and we end up with blood type B. There is no way to get an AB because you can't match across the same person. You're matching one gene from the mom, one gene from the dad together, alleles from the mom and alleles from the dad to get the gene combination. So you can either have blood types A or B, that's it. And last but not least, number 6, a couple has a child with type A blood. If one parent is type O, what are the possible genotypes of the other parent? So we know that one of the parents is blood type O. So we're going to go ahead and fill in that side of the Punnett square. So every one of these is going to have an O. So now the other parent, in order to make a kid with blood type A, we need at least one allele for A. So let's make that this side. Now we've got our A kids, or at least a possibility of them. So what goes over here? We don't know. Could be a lot of possibilities. You could have a parent who is blood type AA, and all the kids could be A. You could have a parent who is a O, and maybe some of the siblings would be blood type O, and this kid just happened to get the A. Or you could have a parent with blood type AB, but the B is not going to affect these two kids, so it honestly doesn't matter. So the parent with blood type A could match that A to any other blood type, and you would still be able to get a kid whose A matched to the O. Hopefully this is making sense, and I wish you the best of luck on these problems. And I'll see you again for sex-linked traits.